Before we dived into today's lesson, we went over some good debugging tips for students to encourage them to not get mad or angry whenever they come across a mistake. Number 1, test one feature at a time. After adding a new behavior, play your game to make sure it works before adding something else. 2, check your connections. Make sure every trigger block is connected to the correct action block. A missing wire is one of the most common mistakes. Number 3, verify collision settings. If collisions aren't working, confirm the correct sprites are selected, such as player, enemy, wall, and collectible. Number 4, check your sprite properties. Make sure objects that should be solid are marked as solid and collectibles are not. Number 5, look for conflicting behaviors. 2 behaviors controlling the same sprite can cause unexpected movement or actions. Number 6, text every possible interaction. Try jumping on enemies, touching them from the sides, collecting items, and hitting walls to make sure each outcome works correctly. Number 7, use animations to verify events. If an animation doesn't play, check that the trigger is connected and correctly and set to loop if needed. Number 8, read your code from start to finish. Follow each connection like a flowchart to make sure that the logic matches what you want the game to do. Number 9, if something breaks, undo your last change. The most recent edit is often where the bug was introduced. Number 10, debug patiently. Every programmer encounters bugs. Solving them is an important part of the learning how to code and build better games. Today, our game developers took another big step in building their platformer games using block coding and Flowlab.io. Students began creating enemy sprites and bringing them to life with looping animations, making their characters feel more dynamic and engaging. Next, they program enemy AI by creating patrol behaviors. Enemies automatically move back and forth, flipping directions whenever they collided with the wall, just like in classic platformer games. After that, students coded game logic to determine how enemies could be defeated. Players could only eliminate an enemy by jumping on top of it, while collisions from left and right caused the player to lose and restart the game. This introduced students to collision detection, conditional logic, and cause and effect programming. To make their games even more exciting, students designed collectible items. They created new sprites, added animations, and made them non-solid so players could collect them and program them to disappear when touched. Throughout the lesson, students practiced computational thinking, debugging, problem solving, and game design as they transformed simple sprites into interactive game elements. Every new behavior they programmed brought their games one step closer to a complete playable experience. Next, we will learn how to add levels in the game user interface and a moving camera. As we finish today's lesson, remember this: you now have the core skills to start creating your own games from your imagination. Every game you've ever played started with someone learning the same fundamentals you learned today. Don't stop here. Experiment with new ideas, add your own characters, create challenging levels, invent unique enemies, and build games that reflect your creativity. The more you practice, the more confident you'll become as a programmer and a game designer. If you don't have access to a laptop, you can still keep learning. Flowlab works on mobile devices too, so you can continue designing, testing, and improving your games right from your phone whenever inspiration strikes. Keep coding, keep creating, keep solving problems. The next great game idea could come from you, and every project you build is another step toward becoming an innovator, developer, and a creator of the future. Thank you.